So we're going to start off this session as always by looking at the last session and our last question. We were asked for the challenge. Amelia writes down a fraction from a fraction wall. It's greater than 1/2 but less than 3/4. So, what is the smallest fraction that Amelia may have written? And what is the greatest fraction that Amelia may have written? Now, with this one, it's really a case of how you're thinking and how you're working through this answer. It's far simpler than it actually sounds. So, pause the video, and I want you to find out the answer to this. Amelia writes down a fraction from a fraction wall. It's greater than 1/2, but less than 3/4. So, what is the smallest fraction that Amelia may have written? And secondly, what is the greatest fraction that Amelia may have written? So, pause the video and come and join me when you have an answer. So with this question, it's going to be the fraction wall that's going to make this easiest. So we know that our fraction is greater than 1/2 but less than 3/4. So the first thing I've done is looked at my fraction wall. I know that anything smaller than 1/2 isn't going to be that fraction. Anything bigger than 3/4 isn't going to be that fraction. So I've got rid of all those fractions smaller than 1/2 that you can see on the left hand side of that purple section. And then any fraction which is bigger than 3/4, which you can see on the right hand purple section. And in that middle bit, you can see the white, you can see all the black lines. That's what I'm interested in. So now I've added on my red line, which is going to go between my two purples. So it starts on 1/2. And what I'm looking for firstly is I'm looking at the answer to what is the smallest fraction that Amelia may have written. We know it's greater than 1/2, but smaller than 3/4. And if I move along, we can see that the very first black line I get, the very first end of the fraction I get after 1/2 is on my 11ths. And if we count, we can see I've got 1/11, 2/11, 3/11, 4/11, 5/11, 6/11. So we can see what is the smallest fraction that Amelia may have made. It's 6/11. That's the very first one I get to after 1/2. The second part, what's the greatest fraction that Amelia may have written? Well, I carry on moving, and what I'm trying to do now is I'm trying to get as close to my 3/4 as possible. And as I move towards that, you can see that I'm starting to pass some black lines. I'm starting to pass through some fractions. So in this one, we can see that I'm just about to go through in my tenths. So I'm going to be going through, in this case, 7/10, but I've still got a couple of lines still there. I'm just on my 7ths, so I'm on 5/7, but I've still got some lines in the way. And we can see that I have my 8/11, which is smaller than my 3/4. So when I'm looking at this question, the smallest fraction that Amelia may have written, which is greater than 1/2 but less than 3/4, is going to be 6/11. And the second fraction, what is the greatest that Amelia may have written, which is greater than 1/2 but less than 3/4, for this one, we'd be looking at 8/11. Now, in our last session, we looked at comparing our fractions, as with our last lesson, last question. But in this lesson, what we're going to be doing is we're going to be comparing two fractions using fraction strips. And we're going to be using this knowledge to allow us to order a set of fractions on a number line, putting them in the correct size. So open up our textbook, we can see that our first problem relates to the work that Olivia and Lewis are doing on their computer screens. And we can see that all their questions relate to fractions and also those symbols we looked at in our previous session, those greater than, less than, and equals. So remember what we did with our dots to help us identify which symbol was which. So for question 1a, we're asked to complete the puzzle for Lewis, and we can see that he's got the first one which relates to two fractions, the second one is two fractions, and the third one is two fractions. And we can see that he's got the coloured number cards. So we're going to use those 4 coloured number cards to complete the 3 sets of fractions. So for set 1, we're asked to look at quarters, and we're looking at that symbol, so we can work out whether that's greater than, less than, or equals to. And once we've worked that out, we know that we're going to be working with quarters. So think about counting in quarters for your first one. So some quarters, are they bigger, smaller, or equal to 3/4? Then we move on to our next one, and we can see that this one, the denominator is missing. So we're looking at 4/8, and again we've got that symbol, and we've got 4 something else. So what will be the denominator? And then for our final problem on that, we're looking at tenths and eighths. And on this one, it's a nice easy symbol for us to be using. So for problem 1a, we're going to complete that puzzle for Lewis. For question 1b, we're going to be looking at Olivia's problem and completing her puzzle. So we can see that we've got 3 different fractions in a sequence here, and again we've got the same symbols used twice in this case. So we're going to firstly find out what those symbols mean. Think about your dots method from yesterday. And then we know that the first fraction we have is 1/8. And then the next fraction is going to be using the number cards 4, 5, 2 or 10. And then the third fraction will be using the 2 cards that are left over. So be thinking about what information we have here to help us out. So now you're going to pause the video and give those problems a go. So question 1a, can you help Lewis solve his puzzle? And for question 1b, can you complete the puzzle for Olivia? So pause the video and come and join me when we can talk about your strategies. So let's begin by looking at question 1a. We're completing the puzzle for Lewis. And the first thing I'm going to do is look at what information I'm given. And again, it's using that greater than, less than or equals to symbol. Now in Lewis's problem, we can see we've got all 3. So what I'm going to do is I'm going to take one which I know definitely is going to be correct, which is our equals to. So I know that I've got some tenths are going to be exactly the same as some eighths. And looking at the number cards that Lewis has, he's got a 4, 5, 2 and 10. So these are all the fractions that I can make out of those 4 numbers using the tenths and the eighths. So we can see we've got 4 tenths, 5 tenths, 2 tenths and 10 tenths. And we've got 4 eighths, 5 eighths, 2 eighths and 10 eighths. And now I'm going to be looking at which of those are equivalent, because we've got our equals, so they're going to be exactly the same size. So now you can see that I've highlighted a section of my eighths bar, and I've highlighted a section of my tenths bar, and I've got my green line just to really show me exactly whether they're exactly the same size. So we can see, for example, on this first one, that 1/8 is bigger than 1/10. Now if we think about the fractions that Lewis could have had, our first fraction that we can look at is that idea of 2 tenths. Now when we look at 2 tenths, we can see that that's not equivalent to any eighths. So we can get rid of 2 tenths and we can move on to our next one, which is 4 tenths. And again, we can see that 4 tenths isn't equivalent to any eighths. So let's move on to 5 tenths. Now in this instance, we can see that 5 tenths matches exactly with a black line on the eighth. So it's going to be equivalent to some eighths. So let's see how many eighths are the same as 5 tenths. And by highlighting both bars, we can see that 5 tenths are equivalent or equal to 4 eighths. So for the first problem we're looking for Lewis, and we're looking at this idea of 4 eighths is the same as 5 tenths. So we got rid of 2 of our cards straight away. We got rid of our 4 and our 5 to create those equivalent fractions. So here we can see that Lewis has used his 5 and his 4 cards. So 5 tenths is equivalent or equal to 4 eighths. And that's going to leave us with our 2 and our 10 cards. So now we're going to look at these quarters. Now we know we got rid of the 4 and 5, so we've got the 2 and the 10. So our biggest question here is, what does the symbol represent? Does that symbol represent greater than, less than, or equals to? And if you remember to our last session, we used the dots to help us recognize these symbols. So our first one, in the green square, we can see that that is less than 1 is less than 3. Our second symbol is greater than. We've got 3 is greater than 1. And our final symbol, of course, we know as equals. As 2 is equal to 2. 2 is the same as 2. So let's look back at Lewis's problem. And here we can see that we're using a less than symbol. So his first fraction is less than 3/4. And to make this inequality statement correct, we can see that we could have 1/4. But one of the big things that we need to do is using the cards that we're left with. We don't have a 1, so we can't write 1/4. We do, however, have a 2. And we can see by looking at our bar models that 2/4 is less than 3/4. So for our next stage of Lewis's problem, Lewis can use the 2 card to show that 2/4 is less than 3/4. Now for the last part of Lewis's problem, we are given 4 eighths is greater than 4 somethings. Now we know that we only have the 10 card left, but we still have to prove that this is correct, because we might have made a mistake somewhere else. So let's check with our bar model and create one which involves tenths. And by creating two bar models, one for eighths and one for tenths, we can see that 4/8 is definitely greater than 4/10. So that leaves us with our last card being 10. So now by using our bar model methods to compare these fractions, compare unlike fractions to check whether they're equivalent or not equivalent, you can see that Lewis has solved this problem as 2/4 is less than 3/4, 4/8 is greater than 4/10, and 5/10 is equal to 4/8. And now we can begin with Olivia's problem. And we can see on Olivia's problem, she's saying 1/8 is smaller than a fraction, which is smaller than another fraction. And we can see that she's using the cards 4, 5, 2, and 10. Once again, I've created every possible fraction that Olivia could have. So we've got 2/4, 2/5, 2/10, 4/2, 4/5, 4/10. And you can see the systematic way that I've used the same numerator with every possible denominator to make sure that I've done every single possible fraction. And as I know that I'm only really working with proper fractions, I've got rid of anything that's an improper fraction. These are ones where your numerator is bigger than your denominator, which means that you're working with more than a whole. And then I'm using a fraction rule, but you could be using bar models or strips of paper to compare these different fractions to see which sizes are going to be correct. Because I know that I'm now looking at 2/4, 2/5, 2/10, 4/5, 4/10, and 5/10, which is one of the reasons why you don't see halves on my fraction wall at the moment, because that would only be improper fractions, which I'm not working with in today's session. Now, using my highlighted 1/8 and my green stick to move along in a nice straight line, I'm going to see which is the very first fraction I'm going to get to after 1/8, because 1/8 is smaller than this, but we know that the third fraction is going to be the biggest of the lot. So we're going to be looking for the next fraction that we'll get to, because then we can say 1/8 is definitely less than that. And we can see the very first fraction we come to is 2/10. So we know that 1/8 is definitely smaller than 2/10. Now we can continue with our journey to find the next fraction that we're going to come across. So remembering that we've used 2/10 already, so now we're looking to see whether it's going to be 2/4, 2/5, 4/5, 4/10, or 5/10. So the next fractions we come to are two of them. We've got our 2/5 and we've got our 4/10. Now, looking at what I've got at the moment, well, I've already used the number 2 and the number 10, so I can't use them again. So that means any form of 10 has to be incorrect, and anything that's 2 in the numerator has to be incorrect. So I'm going to have to continue to see if I've got anything else. And now I've reached 5/10, but again, I've used my 10 already, so I can't be having 5/10 as my next fraction. And now I've arrived at 4/5, and we can see, looking at my cards, I've still got 4 left, I've got 5 left, so my next fraction will be 4/5. 1/8 is less than 2/10, and 2/10 is less than 4/5. Now, if you notice, I didn't use 2/4 in this. So my answer at the moment is 1/8 is less than 2/10. 2/10 is less than 4/5. But what would have happened if I had used 2/4 in this? Because I can use a 2 and a 4. Would I have been able to use a 5 and a 10 as another fraction? Give that a little think for a few moments. So now we've taken a look at our first textbook question and thought about the different strategies and how we can apply our understanding of finding fractions using fraction walls and using bar models and using strips of paper and the like, and number lines, to allow us to identify the size and compare them, and then to actually place them into a sequence, into an order. Now it's time to continue working through the questions in your textbook. And with these problems, think carefully about what you're actually told to help you on your way. And once you've completed the textbook, then it's time to do your independent work in your workbook. So good luck, and I look forward to seeing your work